everyone. My name is Lünig, and I'm a research assistant from the Technische University in Braunschweig. You will present the supporting actuarial cost estimation by linked data, and I will present it together with Sebastian Seiß. And the research is the result of my master thesis. I wrote it in Weimar at the Bauhaus-University, as a chair for construction management, and now we are working on how to estimate calculation and quality costs. Yeah, I will begin with the general problem statement and why we should have a closer look to estimate quality-related costs. Then we explain the development methodology, and then we explain the actuarial cost ontology. We will show the ontology and the SHACL rule by example of a screed inspection, and in the end we will discuss and conclude the paper. Yeah, what's the aim? Why we should have a closer look to quality-related costs? In Germany, we had in the year 2021 16.5 billion euros annual failure elimination costs. That means this cost results from failures and defects in the construction path. And transferred to a project means this, that 4.4% of a project are costs for disposal. And you will believe that many companies estimate these costs, but yeah, just 51% of the construction companies in Germany estimate quality-related costs in the bidding phase. That means 50% of companies do not calculate these costs, and so when you believe that a normal project has about 3% win, you have 4.4 disposal costs which are not calculated, so there's a big difference, and so we decided to have a closer look to these costs. Yeah, quality-related costs are, according to the DIN definition 55350, are divided into three parts. Prevention costs, that are all costs to prevent failures, for example, for training, and then we have appraisal costs, that are costs that result from an inspection. And yeah, we have at the last end, as I said, non-conformity costs, that are all costs that result from a failure. And the DIN says that you're allowed to calculate or estimate these costs by your own criteria. So there is no predefined module, and so we decided for this formula that inspection has a overhead cost part that are fixed. There's a fixed cost part. For example, the transfer to the building, and we have a dynamic part. That means dependent of the number of inspection, the cost it depends on the labor cost on the one hand and the material cost on the other hand. And so what we tried is to transfer this estimation to an ontology, because we have lots of different inspection methods, and so we try to calculate these costs. Yeah, what's the long-term goal of this research? We want to have the appraisal costs on the one hand and to have failure elimination costs on the other hand. Why we should try to compare these costs? In consequence of the comparison, we want to aim that we have error components with a high risk. And so we want to identify these components in an early stage, so that we can have a high inspection method to detect these failures. And yeah, in the end, we like to implement a risk management system that detects failures with building parts with a high failure risks, and so that we can think this 4.4%. Yeah, what's the problem? Why just 50% of the companies calculate these costs? That means the effort values for inspections are implicit knowledge. In comparison to other values, nobody knows really how much time you spend for inspection planning, and this is a complex calculation, and so it's an additional effort. And so we decided to try to calculate these costs, and actually these costs are in the construction site overhead costs of the project. And now Sebastian will go on with the methodology, and then he will present the example.
Thank you, yeah. Exactly, yeah, we followed the log methodology. First we defined the requirements, so we defined the specification, what are the uses that we want to achieve, and our use cases are that we want to describe first inspection, so all quality related costs. In our case, we just want to provide an ontology to describe the appraisal costs that arise when we're doing an inspection, and otherwise we also want to support users to to plan these inspections and also to align these characteristic cost values which are related to an inspection to this specific inspection that they're planning. And more or less, we also want to automate the estimation process, so we want to have an ontology-based estimation tool which inspection planners or quality planners and companies can use to automatically calculate the appraisal cost for the specific inspection. Yeah, because we have so limited time, we just focus then on these appraisal costs. In the next step, we did then the implementation. We used OWL as our ontology language to describe the ontology and to provide the knowledge, and SHACL to provide the optimization, so we can calculate the appraisal costs based on SHACL rules, which are then triggered by the user, and the costs are then estimated. Later, we also want to do then the publication, and of course, an ongoing maintenance, because there is no already done ontology. Like ontology always gets improved, get always better, and there will be also bugs and defects, which has to get fixed and continually improved. Yeah, to do the implementation, we reuse different ontologies, because just to start by scratch and start with an huge ontology, we decided to reuse ontologies. Therefore, we used the Dicon ontology provided by Jürgen. The Dicon ontology provides us with a lot of different entities which are necessary to describe construction workflows, like agents, companies, processes, equipment, so all the stuff we need on construction site, and also all the stuff we need finally to do our inspections too. So this is provided by the Dicon ontology. And then on the other hand, we have the OCQA ontology. The OCQA ontology is providing us then with more detailed knowledge, or more detailed knowledge about the inspection by self. So we have on the one side, we have the Dicon ontology, which provides us with the knowledge of the construction site. On the other side, we have the OCQA with all this inspection knowledge. And then we invented then a new ontology, which is called then the OCQA appraisal costs ontology, which is then extending the OCQA ontology about this appraisal cost approach that we defined. The interesting thing that we also have to show is, we didn't do, of course, we cannot estimate now for all kind of trades the appraisal cost. So this is why we defined then sub-ontologies, which are trade specific. So we have then an OCQA concrete ontology, we have OCQA screed ontology, and screed will be also the example we show today. And because so we can manage the knowledge of the different inspections that we have to do in different trades. So therefore we make a lot of sub-ontologies that we can align again to our top ontologies, or they're following, or to see it on the other way, they're following the top ontologies. So we can see it from bottom up or top down. And this is then the result of our ontology. So on the top we have the Dicon ontology, which is defining, for example, activities, the agents, the equipment, but also providing us with a proper alignment to also other ontologies, like for example then ontologies which will describe the building by itself, for example via IFC-OWL or bot ontology. So we also solve this problem by reusing Dicon. And then on the other way we define then the OCQA ontology, which is then in principle, they make the classes a little bit more specific and add additional classes. Like for example, we added on the class of inspection, which is a subclass, so the inspection by itself is considered as an activity, more or less. And the activity is again aligned to equipment, which is, in our case of the OCQA, is the inspection equipment by itself. And also we added some other stuff which is so far not considered by the Dicon ontology, like for example, inspection or the inspection procedure by itself. So there are no procedures defined, and we have different procedures which can be done to handle inspections. And the OCQAC is then defined on the left side. There you see we have specific costs and cost types. So we have the specific costs which arises during the inspections, and then we have cost types which maybe for construction managers or estimators they know this because finally we want to have in our total estimate we want to have defined cost types. So we want to add all the labor costs which occurs, for example, over different inspection as the cost type labor cost, for example, yeah, or as total appraisal costs. So this is done or provided by the OCQA SC, and then we defined this catalog module inside the OCQA SC, which provides us with the special characteristic values, so hourly rates, or like labor cost hourly dates. So we have these characteristic values, which are used then to calculate the costs by self, or the durations, for example. In our example, we used like this. We want to evaluate the inspection costs for leveling measures in, for example, in a big plant or something like this. So we have a huge screed over slab or a huge slab, and this is screeded, and therefore we want to get sure that this screed is even enough, and therefore we make, for example, in this case, we use a tachymeter to measure if the screed is flat enough over a huge distance. And this is, for example, now the result that we're calculating. In our case, like we have these input values which are defined, for example, by the OCQA by self, so the planned inspection, and then we can run, for example, our SHACL rules, which will use then the characteristic rates or characteristic costs, which are aligned, for example, to a person which is doing the inspection, or, for example, to aligned on the inspection equipment by self, and the SHACL rules are using then the quantities or the duration multiplied with the characteristic values to get then the specific costs, and the specific costs are then, it's just, we just calculated or we just sum up then all the specific costs to the specific cost types we just defined as appraisal costs or as labor costs or material costs. So they're just like the end values, which, for example, the construction site leader wants to know finally just the end sum of all inspection, which are then defined in the cost types. So more or less, that's what we want to achieve here. And our results is that we provide now technology which represents the appraisal cost information and also a lot of knowledge to calculate this with characteristic values that we store in our like a catalog or call it library, where we have characteristic values for each company to calculate the inspection costs or appraisal costs which occur during the project. And also we can now store these values which we're calculating, and we have the possibility to also automate this. And more or less this offers us what we said, like this big goal. We can now evaluate, does an inspection make sense or not? If you also know that in the next step how much it will cost to compensate a failure, for example. But then we can evaluate this and we know like inspection makes sense or not. So we are very close to this mechanical engineering, because there's more or less a standard that they evaluate. Does it make sense to have a failure? Or like, can we live with the failure or not? Because maybe the influence is not that high. So this is what we can also provide now for construction. And the other big thing is that we have now a standardized workflow which can be used by different estimation programs, so they just can run the SHACL rules again and again, and there has not to be some software engineers which develop again and again a catalog which defines characteristic values on rules or functions which will multiply this value with this value, so we can directly provide it, and this is very nice for software engineering because estimation companies, they invent this whole estimation part again and again. So this is also solved by this case and can be used in further software development. Any questions? Maybe as background, we are working also for a big estimation company or like a software company which is providing estimation tools. So this is why we're also focusing on estimations. Thanks a lot.